So this is part 2 of the 1.7 day 3 notes. So you guys just working with tricky absolute value inequalities, solving them and graphing them and writing the answers in interval notation. Now we're going to deal with real-world examples with absolute value inequalities. Now these real-world examples we're going to call our tolerance. So basically what tolerance is, and this is the definition, it's the maximum acceptable deviation of an item from some ideal or mean measurement. Now, let's maybe do some problems so you understand what is happening. Now, there is a formula that you need to know. Make sure you memorize this for the quiz as well as for a test. I will not give this to you, so make sure you remember what this is. It's very important. So let's read example 1. It says a professional baseball should weigh about 5.125 ounces with a tolerance of 0.0125 ounce. We need to write and solve an absolute value inequality that describes the acceptable weights for a baseball. So basically they're just saying that, well, we want an ideal measurement or the weight of a baseball. Now this weight though, okay, can be between two values. So we have some leniency of what the weight can be. It's not everything's going to be perfect, okay? So you should always have some leniency. Now, using this formula, we're going to first write our absolute value inequality. Now, the actual weight, we do not know the actual weight of the baseball. So whenever it always says actual weight or actual height or any of the actuals, when you write your inequality, that will always be x, because we don't know exactly the weight, in this case, of the baseball. Now, ideal means this is what we would like the weight to be. Now, it doesn't mean it's going to be that weight, but that's what we like it. That's actually going to be our 5.125 ounces. That's going to be our ideal, because that's what we would like it to be. That's why they use the word should weigh. Okay, we close the inequalities. Now, finding the tolerance should be easy because they tell us exactly. They say with a tolerance of 0.0125 ounce. Really use those context clues because a lot of times they'll tell you what the tolerance is. So here we just put point and then 0.125. So this would be our absolute value inequality. Now, what we're going to do next, because we're not done, it also said to solve this absolute value inequality. So we are going to find the minimum and maximum weight of the baseball. So remember, to figure this out, we have to create two inequalities. So we have our first inequality as x minus 5.125, which is less than or equal to 0.0125. Our next inequality, we have x minus 5.125. We flip the inequality, so now it's greater than or equal to. And then we negate our number. So we make it negative 0.0125. Now notice here, your tolerance problems will always have a less than or equal to inequality. That will always be true. Okay, so this is a less than, so it's an and problem. Because really we want the weight of the baseball to be between two values. So we have and. So now we're going to solve here. So we add for our first inequality 5.125 to both sides. All right. Now I would suggest maybe doing this on a calculator. It helps a lot. So here we have 0.0125 plus 5.125. Okay, we're going to add those two together. And when you do, you should get about 5.1375. Okay. Now we do the same thing on the other side. We add 5.125 on the second inequality. So 1, 2, 5. And so we have x is now greater than or equal to. Now this is a negative, so we're actually doing negative 0.0125 plus 5.125. And when you plug that into the calculator, you should get 5.1125. Now we're going to treat this and like the original inequalities we saw the other day. So when we wrote our interval notation, because you're going to write your answer as interval notation, right? We used, in this case, because we have equal symbols, right? We're going to use brackets. So we are going to list the smallest number between the two, because this is our lower limit. So we look 5.1125, that is our lower limit, or the lowest amount of weight the baseball can weigh, basically. And then our highest limit is 5.1375. Well, it's the highest limit because it is the biggest number out of the two. So basically, interval notation, this would be your answer when you solved your absolute value inequality. And basically, this is just saying that the weight of the baseball can be between 5.1125 ounces and 5.1375 ounces. And this would be your solution. Now, for our second one, we're actually going to do the opposite. So there, they gave you what the tolerance is, the ideal weight. You just plugged it into the formula, and there we had to do a little bit extra by solving. This case, we're going to do the reverse. They actually give you the answers, and now you have to create the absolute value inequality. Now here's the steps that we're going to do that so we can write our absolute value inequality. So it says the thickness of the mats in the rings, parallel bars and ball events must be between 7.5 inches and 8.25 inches inclusive. So this would be really our answers. So remember we had our interval notation and here was our answer. So we're taking our answer and we're going to go backwards to get our absolute value inequality. Now it says write an absolute value inequality describing the acceptable mat thickness. So here they don't give you what the ideal thickness is or the tolerance. So we have to find that. So what we're going to do is first calculate the mean of the extreme mat thickness. Basically all that means is we have to figure out the average. And when we find the average, this is actually going to be our ideal, okay? So here we take our 7.5 and 8.25. So to find mean, remember we add our numbers. In this case, we only have two numbers. And divide by the how many numbers we have. Well, since we only have two, we just divide by 2. So when we add the numerator, we should get about 15.75. And remember, we're going to divide by 2 on that. Equals, and then we should get 7.875. And really what this is going to be in our inequality is the ideal thickness. This is what we would like it to be. Okay, so we got our ideal. Next, what we have to do is find tolerance. Now, in order to do this, it says you're going to do so by subtracting the mean from the upper extreme. So remember, our mean was the 7.875. So we do, So we do basically our mean, 7.875, and then we subtract it from the upper extreme. Well, what they mean by upper extreme is the bigger number out of the two they gave us. So they gave us 7.5 and 8.25. The upper extreme would be our 8.25 because that's the bigger number. So now what we're going to do is we're going to do 8.25 and then minus our ideal or average. So 7.875. When we do this, we are going to get our tolerance and we should get 0.3 0.375 as our answer. And so this is going to be our tolerance. Okay. So we found the ideal, we found the tolerance. The last step is just to plug in the numbers into the equation. So remember that our equation is the actual, in this case we're talking about thickness, so it'll be the actual thickness minus the ideal thickness, and all of that's in the absolute value bars, which is less than or equal to. We always use this inequality, it never changes. Less than or equal to our tolerance. And so now all we do is we plug that in. Actual will always be your variable, so if you use x, it will always be x, or any variable you use. Ideal, remember that was our 7.875. So we write 7.875. Close the absolute value, and then we write our inequality, which is less than or equal to. Then our tolerance was what we got up there, 0.375. And then this inequality is your solution. And basically these three steps you will always do every single time. You have to write an absolute value inequality given your two values. Okay, so this is what you would get. Now remember, you have any questions on this, you can always email me. I have the filled in notes on the Google Classroom. Just make sure you click the About page if you want to look at that. Also, you can come in before or after schools to receive help.